These are your 5.1b notes on polynomials. So our last notes involved monomials. A monomial means one term, where a polynomial is many terms. Poly means many, so it can be a monomial, or now we can include sums and differences of monomials. So an example of a polynomial would be simply a monomial, 3x, or just 3. So monomials are included in the set of polynomials. So you can multiply these numbers. But we can also now add them, and this is called a binomial for 2. We can add and subtract them, so x squared minus 5x plus 7. There's addition and subtraction of these things. That's what we call a trinomial, 3 terms. Anything above 3 we don't really classify, we just call it a polynomial, so you can have more than 3. So you can multiply, you can add, you can subtract. It can be just variables, it can be numbers and variables. So what's not a polynomial? What wouldn't be a polynomial is, again, division. So if I have a x plus 3 divided by y, that's not allowed. That's not a polynomial, that is a binomial divided by a monomial. So it's a poly divided by a mono. So just keep that in mind. It's like that division, and we're going to actually explore division on its own day. Oh, let me rephrase that too. Another reason that it's not a polynomial is someone might say that I'm multiplying x by a -1. So this x1, it has to be a +1, because really when you simplify that, when you multiply or raise a y to a -1, it is the same thing as division. So sometimes they get away from that way. Some more terminology for you. Terms are the monomials. So when you look at each individual monomial, they're called now terms. Like terms, same variables raised to the same degree. Same variables raised to the same degree. So 3x squared and 5x squared are like terms because they're the same variable raised to the same degree. Doesn't say anything about the number out in front. So like terms, when we can combine like terms, we just add the coefficients. We're going to do that today. Binomial made up of 2 terms, trinomial made up of 3. I talked about that on the last page. And then we talked about finding degree of a monomial in the last section. Remember, we added up the exponents of the monomial. Here, what you're going to do is you just take the highest one. So we're still going to find the degree of each individual monomial, and then the highest degree of the monomial within the polynomial. You don't do a total, and I want to write that down and emphasize that. It's not a total sum. You find each individual degree of each monomial, and then the biggest one is the winner. That becomes the degree of the polynomial. All right, so looking at these 4 examples, we're going to determine whether or not it is a polynomial and then determine its degree. Looking at the first example, the square root of c is kind of throwing me off, and I probably could have given that as a non-example. It's not raised to the first degree or a whole degree. It doesn't have to be the first, but it has to be a whole degree. So it just kind of looks awkward. I don't know if you guys want to add that to that list of not polynomials, but not a polynomial. And the reason it's not a polynomial is because of the square root of c right here. So if it's not a polynomial, we can't give it a degree. Number 2, I see some division there, but the division here is by a number, so it's really 3/4 times, so that's fine. So we look at the degree. The degree of this first monomial is 5. Remember, you add up the exponents of the variables. And then the degree of the second monomial is 9. 2 plus 7 is 9. So yes, it's a polynomial. Yes, it's a poly. And its degree, 9. Don't add them up. You take the biggest one. Number 3, not a polynomial, because you're dividing 2 monomials, so that division of z is incorrect. And number 4, yes, it's a poly. And then when we figure out the degree The first monomial has degree 3. The second monomial has degree 5. The third has 2, so the biggest one wins. So this is a degree 5 polynomial. So that is determining if it is a polynomial, yes or no, and then determining the degree if it is. Now we're going to talk about adding and subtracting these things. You add or subtract the like terms. This seems to be review. I feel like we've been doing this all year, but this is the formal place where we talk about it. Exponents remain the same. So the exponents of the variables remain the same when you're adding or subtracting. So look at number 1 and 2 here. There's parentheses around these numbers, these trinomials, and that can be misleading. A lot of times people see parentheses and they instantly assume we're going to be multiplying. But this little symbol in between the parentheses tells me that in the first example we're adding, and in the second example we're going to subtract. So just be careful of that, be aware of that. So then you may ask, why the heck do they even give you the parentheses? And to answer that question, they want to show you where one trinomial is and what you're adding to the other trinomial. Otherwise, it would be one great big run-on polynomial. So they want to show you, I'm adding this trinomial to the other trinomial, what do I get? So what I like to do is I get rid of my parentheses by distributing a positive 1 through each of them. All it is just rewriting the problem without the parentheses. And so now I've just created one great big polynomial, and I just need to simplify some things. I need to put things in their like spots. So I see a positive 2a cubed here. I have another positive 1a cubed here. So I have a total of 3a cubes. Notice it stayed a cubed. So I like to think of this as we're just putting them in piles. I had 2 different piles of a cubed, so I put them all into one pile. I would have 3a cubes altogether. I have a positive 5a here, so I have 5a's over in that pile. And I have a negative 3a over here. So when I put them together and simplify it, I have positive 2a's. I have a negative 7 coefficient, or constant, and I have a positive 2, which makes negative 5. So as simple as it is, sometimes people multiply and you get a horrendous answer. And other times just people mess up on the exponents or their signs. So just take your time on those. It's extremely important that you distribute the negative through the second example. Because we're subtracting, this negative outside here applies to every single term in that third trinomial, or in that second trinomial. So I have to apply that negative to the x squared, to the 4x, and to the negative 2. So again, I just take a positive 1 out in front here, and I'm going to distribute a negative 1 through here because of the negative sign. So when I distribute a positive 1, everything remains the same, 3x squared minus 2x plus 3. But it eliminates the parentheses. And then I'm going to distribute a negative through negative x squared, negative 4x plus 2. And then now we just clean up. I have 3x squareds over here. I have a negative 1x squared here. That makes positive 2x squareds. I have negative 2x's here, and I have another negative 4x's over here. I have a total of negative 6x's. I have positive 3 here and positive 2 here, which makes a positive 5. And there you have your simplified polynomial. That's adding and subtracting. To multiply, we've already done this. So this is just our formal review of multiplication. We really haven't done a whole lot like number 3, so I'll show you number 3. Multiply the coefficients, multiply the variables. So whatever numbers get multiplied together, and then the variables get multiplied together. If you multiply variables, remember we add the exponents. And then if you can clean up afterward, go for it. So the very first example here, we're just distributing. We're really distributing a 1y. So when I distribute, the 1 and the 4 get multiplied together, that gives me 4. And the y squared get multiplied together, giving me y cubed. Distribute the 1y to the 2y, I get a positive 2y squared. And then the y to the negative 3 gives me negative 3y. Those are unlike terms because they're all different powers. So even though they're all y's, one's a degree 3, one's a degree 2, and one's a degree 1. They cannot be combined. This is in simplest form. Number 2, Distribute, so now I have a number other than 1. So just take your time. The 3 times the 2 makes a 6. The x times the x squared makes an x cubed. And the y times the 1 is just a y. It just stays with it. There's nothing, it's not going to change, but it still has to be part of the problem. A positive 3 times a negative 5 makes negative 15. The x times the x cubed makes x to the 4th. And then the y squared just hangs out. I can't combine those together. This is in simplest form. The last problem here, when we simplify this, we're going to distribute. We cannot FOIL this. I'm multiplying 2 terms by 3. I should get 6 total terms when I'm done. So it's not FOILing, it's distributing. So I need to distribute this a through every term in the second one. So that first a goes to every term of the trinomial. So I get a cubed, that's a times a squared. A times negative 3a gives me a negative 3a squared. And a times 5 gives me a positive 5a. Distribute the 2 now to every term. Positive 2 goes to all 3 of these terms. So I end up with a positive 2a squared, a negative 6a, and a plus 10. And so what we end up with is a cubed. There's nothing alike with it. A negative 3a squared and a positive 2a squared becomes a negative a squared. A positive 5a and a negative 6a makes a negative a, and then plus 10. So this would be our simplified polynomial. What these are going to do, they are going to require that you slow down and you be very precise and perfect with your signs, your multiplication, and your variables. So the lesson summary, I want you to determine the degree of that polynomial, and I want you to actually simplify that multiplication. Good luck.